Let's go back to our hot dog example and take a look at using the t-test to test for a linear relationship. Now previously I went over using the correlation coefficient and comparing it to a value we found from table 11 in the book. Now I want to go ahead and use the corresponding t-test. It's an alternative method. Okay, so just to refresh our memory, we have 10 pairs of data, okay, and we are correlating caloric and sodium content. Okay, so I already have the data inputted into my calculator under list 1 and list 2 from edit. Okay, so here's my X list, here's my Y list. And previously, I went to linear regression AX plus B to get the regression equation and the R value, the correlation coefficient. Now I want to go ahead and go over to tests to get the corresponding t-test. Okay, so again, our null hypothesis is that rho is not equal to 0. Okay, that looks like a P, but it's actually supposed to be the Greek letter rho. Okay, so this is no linear relationship. Versus an alternative of rho is not equal to 0, which would indicate some sort of linear relationship. Okay, so going back to my calculator, I press stat, and then I want to right arrow over to test, and I want to scroll down until I find my linear regression t-test. Here it is. Okay, linear regression t-test. Press enter, and I need to tell it where my X list and my Y list is. For our textbook, we're just testing whether or not rho is equal to 0. Okay, and our calculator has beta and rho equal to 0. Okay, I'm just going to leave it, or not equal to 0. I'm going to leave it at not equal to 0. It does say in the textbook we're only doing equals versus not equals. If we had a positive linear relationship, we could make this alternative greater than 0, and we could also make it less than 0 if we suspect there's a negative linear relationship. But ultimately that doesn't matter, because we can take a look at the sign of R to tell whether or not it's negative or positive, or we can go ahead and look at the scatter plot. Okay, so I want to scroll down and then press calculate. Okay, so it's going to give me a couple of pieces of information. It's going to give me the test statistic for this, and it's about 6.07. And I have a corresponding p-value. Now look at this. It's really small. It's about 2.99 times 10 to the negative 4th power. Okay, so from this p-value, we know we're going to reject the null hypothesis, which is the same conclusion we got before. Okay, we're in favor of stating that there is a linear relationship, and since R was positive, we know that it's a positive linear relationship. Now, in the output, you'll see that we also get the regression equation information. Okay, we'll have the slope, the intercept, and we'll also get R. Keep scrolling down to the bottom. Okay, so it's an alternative way. We're actually testing whether or not the slope is equal to 0 when we're using the t-test. Okay, but you're going to come to the same conclusion, either using the t-test or using R and comparing it to table 11. Okay, again, we could go ahead and write out the regression equation if we wanted, and use it to predict Y values. Now, one last thing as we look at the problem. Okay, previously I went ahead and put in A for predicting sodium content for 170 calories. Now let's take a look at D. Now D is, we're letting X be 210 calories. If we look at the range of values for X, 210 is well outside that range. So it really isn't appropriate to use 210 as a valid input. Okay, the regression equation only works for values that are within this range or fairly close to the endpoints of this range. Okay, so for this particular problem, for part D, we would say that it's not meaningful. Okay, so I hope that is enough information to get you started on simple linear regression.